A sidecar proxy is an application design pattern which abstracts certain networking features such as inter-service communications, monitoring, security, timeouts, retries, circuit breaking, communication protocols such as HTTP, gRPC, all that stuff away from the main architecture of the application. This is to make the maintenance of the app easier and basically to make microservices work. In this video, I want to talk about the following. I want to discuss the sidecar parent, but in order to do that, these are the stuff that we need to go through in order to explain why does it exist. Because if you know me, if you know this channel, anything that exists in software engineering, there is a reason for it to exist. We don't invent anything in software engineering for the sake of inventing things. It's just not for fun or cool, because there's a reason, there's a problem, and trying to solve it. Let's get into it. So the first thing we're going to discuss is the library pattern. Most of you guys know this. You have a C# application and you add a library, a DLL file or DLL library, and then you start consuming functions right inside this library, calling methods, right? In Java you add packages, and in Python you add what do you call modules? You import modules. In Node.js you import packages. Different things, right? But they all fit within the library pattern. We're going to discuss that a little bit. And then we're going to discuss the sidecar pattern. I made a lot of videos about sidecar pattern, but this is more fits like within the microservices architecture, right? I'm going to talk about sidecar pattern. We're going to show some examples why this is actually exists, right? I'm going to talk about some examples, some software example of the sidecar pattern, such as Linkerd and all that stuff, right? And finally, we're going to talk about the pros and cons of SideCar Proxy, because guess what? Nothing is perfect. All right, with that said, we're going to summarize the whole thing. If you're interested to see this stuff, stay tuned. If you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new software engineering video. I specialize in the back end. Let's just jump into this video. So the library pattern. Library pattern is you have an application, you pick a language, this says Java, right? And you basically add a library to your Java that obviously has to be Java as well, right? And then you start consuming methods, right? And we're going to talk about this library pattern within the context of this application, right? So this application, guys, this is a REST API application, right? So there is a server side that is, assume this is Instagram, serving comments, right? So the server side is built on Node.js application, and obviously, since it's a REST API, has to be HTTP. Since it's HTTP, has to be a web server. So there is a Node.js server library, 1.1 to be particular, and that is listening on a port and sitting on your application because you maintain the whole thing. You're responsible of the server and you're responsible for the code behind the server to consume, to actually maybe hit the database, Postgres database, whatever, pull some rows and serialize them and do something with it, right? So that's the server side. And the client side is a Java, not JavaScript, as a Java application, right? So if it's a Java application, it just makes a request to get the comments, let's say, right? I'm going to go through an example. And obviously to communicate with the REST API, the Java application requires what? An HTTP client, because guess what? An HTTP, it's a protocol. In order to talk to HTTP, you need to understand how to talk this protocol. So you need a Java HTTP client library that you import on your Java application so you can make this post request or GET request. It doesn't come for free. Okay, and then you might say, Hussein, this is easy, right? And you make this request, right? You send the GET request and it says, hey, give me all the comments. This is HTTP 1.1, and yeah, you make the request and the server maybe hits another service, or maybe it hits another database and gets back the results and then send it back as a JSON. That's the protocol, that's the format you guys decided on. So it sends back the results. All perfectly working until you decided to add features. What kind of features? Hussein, I heard about this HTTP 2 thing, right? I want to move to HTTP 2. And by the way, when I make this getComments request, sometimes it just it just keeps waiting forever, and I want to implement a timeout in my application, right? So this is a timeout. I need to fail after 60 seconds or 30 seconds or maybe 1 second, right? Because if it's taking more than 1 second, probably it's not gonna come back. And because I implemented timeout, I need to implement retries. So I'm going to retry after all of that stuff. So you start building these features: circuit breaking, retries, timeouts, HTTP2. It's not easy to implement HTTP2 library, by the way. You start putting a Java code in your HTTP client library. So you start doing all these retries and all these timeouts. It's all code that you are responsible for writing. And obviously, the moment you start doing that, you gotta do the same thing on the server, right? Then you start replicating the same code, but in Node.js, because your server, for some reason, is different than your client, maintained by 2 different teams, right? That's a lot of work. And guess what? None of this work is actually your application. It's all networking stuff, right? So you implemented this HTTP2 library and you made it to this thick server and thick client, and it's now working, right? Make a GET request, HTTP2 gets request. Now I'm taking advantage of the multiplexing and all that jazz. By the way, guys, we talked about HTTP2. I'm going to reference the video here if you're interested to see that. And then you get back the results and that JSON, and that works. But look at all the works. If there's one single bug here, you go and have to fix this library and you have to recompile your entire Java application despite fixing a stinking bug in your client library. This is your code. This is the meat and potato of the comments API, which you take that comment, maybe you translate it, and instead of focusing on features of the actual core application, you're wasting your time writing networking API. Okay, so that's the core problem here, wasting time building this stuff. And in the next time HTTP3 comes, you have to do this work all over again. Yes, a lot of work, duplicate work. So, plus you're stuck with Java, right? So if another application wants to now, like if another team wants to start consuming this application, right? They have to start with Java. Guess what? Because all the client library is in Java. You have to start working on Java. And you might not want to do that, right? Meet the SideCar Proxy. So he said, okay, here's what we're going to do. We're going to take advantage of this idea of proxying and all these beautiful features that you have built, right? Split them into its own bubble of an application, okay? And Java or not, you don't care. Build it in Java, that's fine, right? And then listen to a specific port here. And then build all these functionality, the networking functionality on this proxy, right? This is your HTTP2 proxy with the retries and everything. And your Java application now doesn't no longer import a DLL or, well, there are no DLLs in Java. There's jar files, whatever you call them, right? Or C# doesn't no longer import DLL files. Your Node.js doesn't import packages anymore. All you need to do is spin up this application that the networking application, the server that you built on, and make it listen on your same local host where your application is running. When you spin up this proxy server that you have built with the networking features that you have built, specify in your proxy settings on the application that every single layer 7 HTTP request goes through this application, which is maybe localhost 8080 or localhost 9000, right? And the moment you do that, any request that is titled destined to this server will first go through this. That's how a proxy works, right? That's how a forward proxy works. Any request will first go to this, right? And then magically the proxy that you have built, the SideCar Proxy, will make a request on your behalf. It's going to use the HTTP2 protocol. It's going to do retries if it does have to. It's going to do the accurate timeouts. It's going to do all these features for you. You might say, Hussein, what's the communication between this and this, right? This could be a just normal HTTP 1.1 insecure. You don't even need to implement security between this and that and this guy. And then once you make this request, the other complete mirror of the same application, you can put it this way, right? The same SideCar proxy, spin it up on the other side, but as a reverse proxy, right? So this is one of the few cases where a proxy act also as a reverse proxy. I can't think of any other use case where a proxy acts also as a reverse proxy. A same application does two jobs. I can never think of other proxy other than this service mesh scenario and sidecar pattern. This is the only case where I can think of it, right? Very interesting, right? And if you're interested about reverse proxy and proxy, I'm going to reference the video that I made about proxies and reverse proxy. So obviously you make a request to the reverse proxy. These guys talk to each other and they specify, hey, I'm going to that, right, application, and it distance to this proxy. And that proxy, the reverse proxy, will obviously, because it's a reverse proxy, it's going to hide the identity of the server, right? And now this guy doesn't know the server, right? It actually knows the reverse proxy. And then it makes a request on its behalf to the actual Node.js server, right? And this could be just a normal HTTP 1.1. Who cares, right? And then Node.js now responds back to the same reverse proxy, just as think of the reverse proxy as a client in this case. A request response, and once it gets a response, it will respond back to the JSON format. And here's the beautiful part, guys. If you decided to change the format from JSON to protocol buffer, just like that, you implement this feature here and here, and those applications have no idea that you have done that, and they should not care. You can implement protocol buffer between those puppies and get benefit of the compressed binary efficient size, right? And do that, right? Obviously, once you get a result, you send it back to the actual application. So this is the sidecar proxy aspects, guys, right? And usually these guys live in the same host, right? And if they are containers, they are two distinct containers that have the same local host. It's just magic, guys. It's just magic. If it's two applications running in the local host, that's easy, right? This is, let's assume this is your MacBook and you have one application running on port 8081 and this is running in 8080. That's totally fine. Docker containers, they have something, this is called I forgot what's called, networking, where two containers can have the same local host. So if they communicate with each other, they actually can talk to each other as if they are the same thing, okay? Which is pretty powerful. All right, example of sidecar. What are examples of sidecar proxies, right? Service mesh proxies are a best example where microservices, the moment microservices were born, sidecar pattern blew up, right? And service mesh as a result became very popular. I think Linkerd was the first to come to market, right? Twitter started kind of an idea of a sidecar pattern, but they used library called Finagle, right? So everything was a library that built, I think, a Scala. I might be wrong there. And they used all these libraries and they forced everybody in the company to write in Scala because that's the only library you can communicate for networking. Linkerd changed this, right? Linkerd is a sidecar proxy. You can spin it as a container where you can use any language you want. I don't care. Make a request, make your proxy as a Linkerd container, and then I will take care of their request. So there was always a Linkerd forward proxy and a Linkerd reverse proxy. Same thing with Istio. I think Istio comes from Google, and Envoy comes from Lyft, I believe. Linkerd is a company from Buoyant. And the founder of this, William Morgan, he used to work for Twitter. So he took the idea and made it into this service mesh. The sidecar proxy container, if it's a proxy, which is an application, you can just spin it up as a container. And that's where you're going to hear this term, a sidecar container or a sidecar proxy. It's exactly the same thing, right? Sidecar proxy, It's an application that runs as a container, right? So if I say SideCar container, that means it is as if like this is like a sidecar sitting beside another actual application container, and both of them have the same local host so they can communicate with each other. And here's another thing that we must really understand, guys, as a software engineers. Sidecar containers or sidecar proxies must be layer 7 proxies. What does that mean? That means they look at that final layer, and if the moment they look, that means they see your data. They have to. There is no escape from looking from your data, because if they don't look, then how can they implement all these beautiful features for you? Security and retries and timeouts and service discovery. They cannot do any of that stuff if they cannot look at your request. So because we talked about this different type of layer 4 proxies and layer 7 proxies, and we talked about the advantages and disadvantages in this channel, and when you want to use a layer 7 proxy versus a layer 4 proxy or load balancer, right? It's just very, very similar, right? Pros and cons of SideCar Proxy. Is this thing perfect? No, but it has a lot of advantages, and I can find very few disadvantages. And if you can think of more, let me know. So the first thing is the pros. It's a language agnostic. It's called polyglot architecture, okay? Where you can pick any language you want, son. Java, C#. Because the networking layer is now separated, all you need to do is just make a simple HTTP 1.1 request to the SideCar proxy. And the moment you make that, we will take care, the SideCar proxy will take care of upgrading that stuff. It's going to use HTTP 2, maybe Quick in the future. It's going to use protocol buffer if you tweak it in a better way. Maybe it's going to use gRPC. Who cares, right? You make a simple request. You still need a client library. Let's be honest, right, guys? It's not for free. But you're language agnostic. You can use any language on the back end, any language on the front end. Even they are different, that's okay, and you don't have to worry about the networking aspect of it. Protocol upgrade, we just talked about that, right? You can just make an HTTP 1.1 request, right? But that will be can be upgraded if you want to, right? In the actual wire, which is where the cost is, to HTTP 2, right? And take advantage of the multiplexing and all these very wonderful features. Maybe you can use gRPC, right? And then and take care of about like streaming model, and take care of bidirectional functionalities. All that's beautiful stuff. Security. Why would you say I care about security? Authentication, guys. Let's say this comments function, you are not supposed to call this server for any reason. It's being pulled from the network, right? How do you know that, right? You can implement these security features in the proxy itself, right? And Linkerd actually and Istio does that for you. They have something called the control plane, where you go and muck with the configuration. Say, oh, service A can no longer talk to service B. Done. That's it. You just stop the communication right there. Without the SideCar pattern, you can never do this. You have to go to each client and literally muck with the client library to stop making a call to a certain server. Okay. Tracing and monitoring. If you want to trace a call, right, a request, you can use the SideCar pattern to uniquely identify each request, right, and make a logging, like have a logging service where you log your stuff and then take measure how long each request takes, right, to your tail latencies, all that stuff, and produce like a Grafana dashboard and do all that beautiful stuff, right? And showed like a nice dashboard of everything. Service discovery, right? And the moment you start talking about service discovery, this is a whole topic by itself, right? You make a request to, I say, hey, I want to go to serve the comment service, right? And the comment service, it's literally just a string, it's a HTTP comment service, but it doesn't even exist as a host. But what the SideCar proxy does, it will take that and it will query some service to find, okay, what IP addresses this comment service exists on, and we'll return a bunch of IP addresses, and it will establish this communication TLS termination, securities, certificates, all that stuff is being taken care of in the SideCar Proxy, guys. It is powerful stuff, right? I feel like I'm advertising a lot for this thing. Okay, I need to say some bad stuff about this technology in a minute. Caching, because it's a proxy, definitely it has a benefit, just inherits the benefits of caching, and pretty much any benefit for the proxies, right? All right, you cache stuff, yeah? You can make a request and it caches that request, and if you make it again, then it says, hey, you just made this request, and it's this almost the same timestamp, right? You don't have to make it again. Cons, what's bad about this? It's funny that it's only two things, but it's a very, 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 very important thing to know. This is a complex system to implement, sir. This is a complex system. I always jokingly say that microservices is the process of breaking down your application into smaller services across the network so you can add latency and make things run slower. and not only that, you can also make things absolutely nightmarish to debug, right? That's what microservices gives you, complexity, right? Because the moment you start breaking things up into from a powerful method call, which is the library pattern, into a network call, you're prone to failures, you're prone to latencies, you are essentially just killed yourself, right? You shot yourself in the foot. You introduce a complex system, and those guys from Linkerd and Istio and Envoy says, yeah, we have a solution for this. Wait a second, don't worry. Yeah, you broke your application into 700 services, but never worry about that, sir. Just add 2 more containers or 2 more services for each of your service, and you'll be good to go. That's exactly what they did, right? So your services now, you had one application, right? You broke it down into 700 services, and that's not the end of the story, by the way, because you started using the library pattern, right? But in a networking fashion. So now it says, oh, for all of these 700 services that you have built, add another 700 times 2, right? Because every service will have essentially no, really. It's just every service will have a container by its side, a sidecar container, right? Or a sidecar proxy. So yeah, just add another 700 services. So you have, like, instead of having 700 services, now you have 1400 services. Okay. Now the next question comes is how the heck I manage 1700 containers, right? Or 1400 containers. Oh, that's easy. Google came in and says, oh, no, we're going to fix this for you. Here's Kubernetes. It's going to manage everything for you, and it's going to make everything rosy, right? So sometimes I think we're shooting ourselves in the foot for absolutely no reasons. But that's just too politically. So we're going to stop talking about it. But yeah, it's a complex system. If you're Google or Netflix, then you can afford the resources to do all that stuff. But if you're just running a 2-man shop or 2-woman shop, probably you don't have to do all that stuff, right? It's fun to talk about. It's pretty thought provocative to talk about it as a software engineer. It's fun. It's cool, quote unquote cool, but is it really necessary? I don't know, sir. You tell me. Latency! Obviously, networking deals with latency. And the moment you start breaking things up, you have latency. Even in the local host, right? It's a call from local host, but it's prone to failure, right? Proxies, it goes through a network stack, and still things can get prone to failure. Nothing is better than a metal silicon call, which is the library. Now you're just shifting it to a network call, which is prone to failures. Right? UDP might solve this problem. Well, will reduce the latencies because there is no additional handshake and what's not, right? It's a connectionless system. But who knows? All right, summary. All right, guys. So we talked about the library pattern. We talked about this. This still exists, still powerful pattern where you add basically a bunch of DLLs in case of your VB.NET application or C# application, or you add packages in case of Java, you add packages in case of Python or Node.js, and then you use these things, and you're responsible. They have to be the same language you're using. It's powerful because you make a call, it's the same computer, it's the same silicon, it's all funneling through the same circuitry, right? So that's a library pattern. It has its limitation, obviously, because you have the limited by the language, right? But if you don't care, who cares, right? And yeah, you're limited by the features you're adding. You start adding these features here, right? Sidecar pattern is the pattern. We talked about that. It's just split things that are not necessarily the core application job, but split up into a proxy, a forward proxy. And I make the request normally, but the proxy will take care of it because it's actually configured in my settings as a proxy, right? And we made a video about this kind of proxying videos as well, guys. I'm gonna reference the videos, right? We got to talk about some sidecar examples like Linkerd, Istio, and the Envoy and other services, I think. We talked about pros and cons of SideCar Proxy. It is not as simple to implement. It's complex and it's going to increase latency. Complexity increase maintenance, and maintenance means cost, and cost means money, I think, and headache probably. Yeah, so you end up doing, from maintaining one single VM probably to maintaining a Kubernetes cluster with 700,000 containers. And you might ask yourself, like, why did I do that? And we talked about that stuff. Hopefully you enjoyed this video. A little bit short, and I'm gonna see you in the next one. What should I make next? Tell me in the comment section below. Thank you so much for watching. See you in the next one. You guys stay awesome.